Go live. Whoops.
We're live.
We are live, and I lost you guys. Wait a minute. I'll get you back right now, I hope. Hello. Welcome to our weekly Monday morning, 11 to noon virtual podcast, everybody. We're the South Coast Longtime Astronomy and Telescope Club, the Santa Barbara Astronomical Unit. We call it the SBAU Astro Hour, and it features members of our Brain Trust, our board members, me, your host, Baron Ron Heron, keeping the old club alive here for members of the SBAU and people that might want to join as well. SBAU.org is how you find out all about us. And I just lost the screen, but I guess I hit the wrong button, but it went white, and I'll figure out how to get back to seeing you guys here in a minute. This hour, on, I believe, our 44th episode, last week of the year, the 27th through, I guess, the new year. Peekaboo star cluster, maybe. We might talk about a blue snowball. We'll visit our smallest planet, perhaps. A Christmas photo of Comet Leonard taken over Namibia, a desert country in southern Africa. Big lineup of the moon and 4 planets we can all see. 2 planets you can't, you're going to need lenses. Speaking of lenses, we're going to capture the sky with your smartphone at the end of the show. Let's meet the crowd, the gang. President Jerry Wilson, how are you, sir?
Good morning.
Good morning. Ready for New Year's Eve. Your wife, the lovely Pat Forgy. And also married to a Pat, who is our merchandise manager, Chuck McPartland, outreach coordinator.
Good morning.
Morning there, sir. We have on the screen as well Tom Totten, webmaster, technical wizard. He is the wizard. Come forward. The incredible Tom Totten has every intention of granting your request. He's also a former president. His wife is Suzanne, the artist. Bruce Murdock has joined us. He's married to Bonnie, longtime active member, president of the Santa Barbara Theater Organ Society. And as well as Tom Whittemore, whose wife is Maureen Whittemore. Everybody's a member of the club, former West Point.
Maureen O'Rourke.
Good morning,
Maureen
there.
O'Rourke.
Well, what do you say? I didn't
Maureen
hear.
O'Rourke.
What did I? Maureen O'Rourke?
Yes.
Oh, okay. I didn't know that. I think I met her once when she was working at the Comet Clinic. You edit our newsletter.
Yep.
Have we gotten it yet? It's coming, isn't it? For January?
No, I'm working on it because Bruce recently sent me that beautiful image of the green flash, and I would love to put that on the front page. It's just gorgeous. We also saw that from here, but of course with our eyes. This amazing green flash.
Can we see that now, Tom?
Tom's got Bruce's image.
Let's explain the green flash. Who wants to tell us what that is?
I can
Bruce.
shoot.
It's his picture.
That pretty.
Well, the green flash is caused by chromatic aberration in our atmosphere.
Yeah.
Red light is bent more than green light is bent more than blue light. And the red light is bent below the horizon. That's what causes red sunsets.
Right.
The blue light is scattered by our atmosphere. That's why we have a blue sky. And what's left is green. So as the sun is setting, the last rays that you see are green. But it requires a very laminar atmosphere, and even in these pictures, there's a lot of turbulence.
And you got that at sunset here?
That was 300 feet from my house on the Bluffs from Vista.
Yeah.
Oh,
And
you look okay. That's how you did that then.
We saw it from our backyard. It was really beautiful.
But you don't always see one, do you?
no,
No, but I know when you can. So we've seen a number of them up here. So yeah, there are a lot of components to the green flash, and one of them, as Bruce mentioned, is that prismatic atmospheric refraction. Okay, that basically separates the colors, from the purple or blue all the way out to the red. But you also have to eliminate the blue, and that's done by Rayleigh scattering. So there's particle scattering in the atmosphere that remove that. And you're left with green and some other colors. And so you basically have to have a fairly steady sea, okay, to basically lift that little piece of sun just before it dips down below the horizon. So it's a long time ago, Alex Filipenko did a really good little video on, what goes into a true green flash. And like Bruce's thing shows there too, I see it as turquoise. I always see it as turquoise. It's really pretty.
Yeah, there's actually a little bit of purple in there, again, due to atmospheric turbulence.
Boy, that's dead green to me. I guess everybody's eyes are a little different.
Yeah, I'm seeing a lot of purple on the very, very smaller ones on the right
Yeah.
side.
Yeah.
Right.
Yes. And I think Bruce aren't those shot like 200 milliseconds apart, something like
Right,
that?
they're 5 frames per second, 200 milliseconds apart. So this shows you how fleeting it is.
Yeah.
It's
It's
just
all
a
And
over.
you
second.
actually don't see it move. You don't actually see it move along the horizon like that, but Bruce
No.
pasted them together to show the.
That's right. Right.
I thought that was a better way of presenting it
It
than
is
having
very, very.
Oh, it's really, it's Bruce, it's the work of an artist.
So
Send that to Astronomy magazine. They might print that sucker.
Oh,
Can
I
you-
think it's been on Edhat, right, Bruce?
what's that?
Pardon?
I think it was on, wasn't it on Edhat?
Oh yeah, and I got, I don't know, 15 very nice comments, and
Oh,
I mean, I can forward the link to, I think that was Edhat either on the 21st or the 22nd.
Yeah, there it
Can you-
is.
Can you also see a green flash at dawn?
I guess you could technically, but I never heard of it.
yeah.
Really?
And he even
The
got
problem
three.
is knowing where to look.
Yeah.
Say, hey, Chuck, he got 3 pelicans in there. There's not 7.
Yeah. Well, they go in groups of 1, 2, 4, and 7. So that's a group of 2 and a group of 1.
Wow. Heard about it all my life. Never
So
seen
when
one.
you see the sunset and it's broken up into layers, that is, it's not a perfectly round orb when it sets.
Right.
When it's layered, coming at the last minute before it goes down, that's when you need to pay attention because you might get a chance to see the green
Yeah,
flash.
that's exactly right. And the sun appears like an anvil. You know,
I was
when
going to
you
say
really get-
that.
Yeah.
Right.
So this
I think
would
I
be-
forwarded a picture of that to you, did I not, Tom?
Yeah. It's really, really
A
nice.
collage of four
Yeah.
other green flashes that I'd taken, one of which, or several of which, they look like an anvil.
Yeah.
The sun
Yeah,
looks like an
that's how
anvil.
you know you're going to probably get it. If you watch the sun basically get separated. There it is. There it is.
That's a green flash?
Yeah,
Mhm.
see the
Oh, I
green
see.
part.
Down at the bottom, it's, yeah, I see, got it.
Beautiful.
You can see the layers in the atmosphere too. That's
Right.
why you get multiple
Yeah.
greens in there.
Why is there a curve beneath it? Is that the curve of the Earth?
That's the orb of the sun, yeah.
Oh, that's the sun.
The
Yeah,
sun.
yeah,
Right, but it
Question-
gets distorted. It's no longer a portion of the sphere.
yeah.
Question for Tom Totten, our webmaster. Can our members see this incredible photograph on
Yes.
SBAU.org? That archive?
It's right now, it's just on our program, but
They can watch our whole program.
Yeah.
Okay.
I asked Bruce if I could put it on the front page. And he-
Certainly.
Yeah.
Oh,
I have some comments on it list from Jim Williams says, he's seen that exactly once. And Tim Crawford says a great image, and Tim Crawford calls the color purple.
Purple.
That's pretty good.
And then Jim Williams says, men are inclined to be colorblind in greens and blues. So that might make have an effect on some people looking at it, I guess.
Yeah.
Mhm.
but you can only see it on the ocean, the flat.
No, I've actually seen green flashes off of mountains.
Really?
I saw one off of just as the cloud, there was a fog, a low fog. I
Mhm.
sent you a picture of that too. And as it went below the fog, the last thing you saw was green
Yeah.
Isn't that cool? Yeah.
for the same reasons.
Yeah.
Yeah, okay. So a green flash follows the sunset across the Earth, sort of like a trail of a sonic boom in a airplane in a
No,
way.
it's totally local, Ron. It just depends on your atmospheric conditions.
Right.
Well, I know that, but somebody 1,000 miles west of us sees it in a few seconds later.
Not if they don't have the right atmospheric condions.
Right.
Oh, it's got to be atmosphere. Okay.
It's pretty touchy stuff, Ron. It's pretty touchy.
Well, it sounds like a
Seen
You got it.
dozens of
yeah, it's
they're all
like
spectacular.
holy grail. Can we
If-
call up
if-
some of Jerry's forwarded cartoons? Start with a little lightness here. I like this one, Nothing to Watch. That's what I'm saying, nothing to watch. It's pretty much an encapsulation of why we have the club, why there are astronomy clubs everywhere, why astronomy is really big. Oh, wrong one. Here it is. Yeah, can you blow that up?
Yeah.
Oh, yeah.
Nice encapsulated way of describing why we maintain the club, like SBAU, mom and dad, loudly inside lamenting, nothing on TV. There's just absolutely nothing to watch tonight.
Right.
Outside, the teenage sun is shown lying right there on the roof with plenty to watch.
That's pretty neat.
That's a classic.
Yeah.
Can you go back to that other one and we'll get it out of the way? A little prehistory from the prophet. This be the lady standing in the prehistoric wife entrance to the cave while her Neanderthal husband puts drawings up on the wall, futuristic boats and locomotives, a rocket ship, even the wheel. Poor woman is saying, okay, when I asked what your future plans are, I meant as far as hunting for something to eat, for crying out loud.
Pretty
I
good.
suppose we want to find Edgar Ocampo's wine statement. That was something he sent out. You can see Edgar. I guess he's back. That's funny. I like that. Do not think we found any hieroglyphs like that, though, on anything. Although they do have some spacemen on the walls of rocks, don't you?
Yeah, I was going to say, unless you're.
Yeah.
That's just ignorance shining through.
Yeah.
Also in Peru, the spaceman on the mountain and whatnot, Nazca planes.
Oh, look at this. This is a new nebula just found for Christmas. What happened to the Horsehead Nebula?
The LCAD Nebula.
Yeah, that's classic stuff. That's really great.
Pretty good.
It needs a red nose.
Yeah.
Oh, it
Yeah.
does. That's actually in the middle of Orion's gases. That's really dinky, isn't it? It looks large when you see it close up like this, but
It's
Yes.
actually
End of
quite
his
large
belt.
in a telescope.
Is
It's faint. It's faint though.
Yeah. It looks like a big thumbprint.
And it's always good to have a filter, special filter to see it.
Yeah, an
Is
H beta
this-
filter.
Is this
Mhm.
near the belt of Orion?
Yes.
It's at the end.
Yeah.
but my question is, the dark part that forms what looks like a horse's head, is that the gas or is that a break, an opening in the gas?
So
That's
it's
the
an
gas.
obscuring dust cloud.
Is that close to the towers of creation?
No.
No,
Those are, but they're in the same Orion nebula.
No. The pillars of creation are off in the summertime sky
Oh, okay,
in the
gotcha.
Eagle Nebula.
Yeah. Aquila.
Tom
Yeah,
Totten,
this
is it possible before we get into our subject matter to pull up a Christmas photo of Leonard taking over Namibia? Or do you want to go, you want to go to this?
Yeah.
This is the video, right?
No,
No, this is
Oh,
just
no.
photo. It's
this
like-
is a joke. This is the first image sent back from the Webb telescope, but it's a joke.
Yeah.
But it's a real image.
No,
No.
it's a joke. Ron.
No.
It's
It's a real
Photoshop.
image, but not taken by James West.
Yeah.
Removed
Webb, I mean.
before flight.
It's on the inside of or it's on the lens cap.
Yeah.
All
It means
right.
someone forgot to remove the lens cap. But it's not true.
Yeah.
It's just a joke.
Well,
It'd be an
we're-
expensive joke.
Yeah.
Jerry, I'm looking at you to give us an update with a moving description there, the graphics that I guess NASA has sent us of where James Webb is. But I wanted to share with that Leonard, that comet thing that was in the middle of your talking points, I think. Totten, how hard is it to go to the middle of his talking points and find that picture of
Well,
Leonard?
there's a really nice one today on spaceweather.com showing a disconnect event in the tail.
Oh,
and
yeah.
Another
yeah.
image that shows the tail is now 36 degrees long.
Wow. Whoa.
Yeah.
How come I keep seeing different pictures of the tail going up, going sideways, going down?
That's just which way they rotate the camera.
Is that what it is?
Yeah.
You would think they'd want to put it in the sky as it looks. Here we go. What are we
Oh my God.
watching?
Oh, Lord.
Comet Leonard's giant tail. Now, Venus was supposed to get meteors on its atmosphere, but we didn't see them, did we?
I don't know if anybody saw them. I haven't seen any follow-up on that.
No, I haven't either.
That means it went pretty close to Venus. It didn't come close to us, though.
No.
That's correct.
Venus on the other side of the sun.
It was about 3 million miles from Venus.
Got it.
Yeah, Venus
All right.
is actually on our side of the sun right now.
Mhm.
Somebody camping out in the desert of Namibia took a good picture, and Jerry sent it to us.
Actually, it's a German photographer, and he just has a remotely operated telescope in Namibia.
Is that right? That's a fascinating country. I've been visiting there, both YouTube. Can we talk about JWST? It's barely there. It's I thought it would be halfway there already, and then I got
Oh,
to
no,
remember-
it's going to take a month, Ron. Going to
Yeah,
take a
I
month
know, a million
to get to
miles,
L2. Yeah.
because the moon is about a quarter of that distance, and it took our Apollo astronauts 3 or 4 days to get
Yeah,
there.
but they were slowing down to land.
Yeah.
James Webb is not slowing down to land.
Not going the same speed to get there.
Oh, it's going much faster.
I know they were backwards. Can you call up that video, YouTube, NASA?
I can tell by Tom's expression he's working on it.
I'm working on it. Yeah.
This is, I guess, available to everybody. There's all kinds of James Webb stuff on YouTube's menu for me. There we go. Yes, great. Describe this, Jerry, or Tom, Tim.
I think it's pretty self-explanatory. We're about, 10% of the way along the line. Early deployment. You can see the distance from Earth is changing in real time up there, and the distance to the L2, the second Lagrange point, and that's its orbital station.
And the moon is there.
Yeah, it's 27% distance complete.
27%.
It's doing 0.75, 3/4 of a mile per second.
Yeah.
It's like me going to work.
And your new Tesla. Got it. So is it going to be a long curved trajectory, or is it just going straight out?
No, it's just a straightened timeline here, but it's a long curved orbital combination.
And it's going to take a month. And by the time it gets there, well, it's out of the cone now. Isn't it? All the rocket stuff's gone. It's just by itself.
Well, this picture that you see underneath is showing the configuration and how they've raised the antenna.
I know, but it's out of the cone. It's out of
Yeah,
totally
you
out
can
of the
see
rocket.
it's out of the cone. There it is. You can see the mirror segment.
The shroud is off. The shroud comes off as soon as they get out of the atmosphere, because it's extra dead weight. They don't want to have to accelerate.
Wonder what happens to the rest of that rocket. Does it stay out there, or does it plummet back to Earth? Does anybody know?
Probably is in a short-term low Earth orbit and
Yeah.
eventually re-enters.
Yeah.
And it's
We
got
do have some second stage things that have been orbiting the sun along with the Earth, and periodically we pick it up again as a sort of a false moon or second moon or whatever they call it.
There you go. Look at that. A lot of unfolding.
Yeah, the origami satellite.
Yeah.
And somehow those hexagons have got to form a concave within a tolerance of 1/1,000,000th of a hair or something. Good Lord.
No, it's within about 1/10 of a wavelength of light. But you got to remember that the wavelength of light it's looking at is very long wavelength. So it's a much easier requirement than we have on our visible mirrors that we make in the club. So it's still a precise mirror, but it's doable.
Over 1 million.
Well, they have
parts.
micro manipulators on the various elements of that mirror, so they can test
Right.
it.
Yeah.
And it's always going to be facing away from Earth and away from the sun.
Away from the sun, yeah, and it's behind the Earth in the Earth's shadow.
Yeah.
They're deploying the heat shields now. There'll be 5 layers of that mylar stuff to reflect back the radiant energy from the hot Earth and whatever's out there, this sunlight going around the Earth.
Tim is asking a question about that somebody said that James Webb was slowed down. So for the arrival.
For the arrival on station.
Yeah, does that make any sense that somebody?
Yeah, it speeds up and slows down in order to adjust its orbital trajectories. And then the combination of all these adjustments have it end up right at the L2 point at the right velocity to continue in orbit around the sun in lockstep with the Earth. So yeah.
Well, isn't it in a ballistic orbit that is designed to have it slow down because of the Earth's gravity as it approaches L2?
Yeah, it uses the Earth's gravity.
It also has an insertion burn that it does to slow
Yeah.
down. So
Okay.
Yeah, when its engine is off, then it's ballistic. It's just
Ballistic.
coasting through through gravitational fields of the Earth and the Moon and the Sun, so it has a resultant ballistic trajectory. They change that ballistic trajectory whenever they have an engine burn.
I'm surprised that they have the mirror uncovered now, and then they're going to do a rocket burn, which
well, I don't know if it's a rocket. They're going to have some kind of way of slowing it down. It might be a ion thing.
Okay.
Would it be fair to say that the James Webb will be parked at 94 million miles from the sun, whereas the Earth will be 93, the old AU?
Roughly.
I mean, it's in its own orbit, right? I mean, it's
Yeah.
in an orbit next to ours.
It's in a synchronous orbit with the Earth.
Yeah. And it's 1 million miles farther. So that would be fair to say.
Well, it's not geosynchronous. That's 23,000 miles where they put the TV.
That's relative to the Earth's rotation, but this is relative to the Earth's revolution. So it's
and it stays out there. And
That picture shows it.
yeah.
how many points are there? 4?
Five.
Five.
Where's the 5th? I count for 4.
Down at the bottom.
Bottom, L5.
Look over for L3 across the opposite side of the sun.
Mhm.
Oh, there's one halfway between it. Oh,
Yeah.
I see. Gotcha. Right. I see the missing one,
Yeah.
L1.
L4 and L5 are 120 degrees apart.
Mhm.
You suppose we'll have something someday in the future at all of those points?
And the L4 and the L5 points for Jupiter are what causes the Trojan satellites,
Right.
Oh, yeah.
or asteroids, yeah.
I learned that the other day, and we're on our way there, aren't we?
Yes.
To visit both of them, both sides of Jupiter, I think, in a year. What is that?
L3 is not stable.
Right.
What does that mean, Bruce?
That you can't park a satellite there without actively keeping it there. If it gets a little bit too far away from Earth, the gravity drops and the sun sucks it in. If it gets a little too close to Earth, the Earth's gravity is stronger and the Earth sucks it in.
So it's going to L2.
Mhm.
L2 is stable.
L3 is toward the sun.
It's on the other side of the sun.
Yeah.
Oh, it's on the other side of the sun.
There it is.
That's the sun in the middle. Okay, got it. Fascinating stuff. Wow. Well, we'll park something there someday. I don't know what.
No, I don't think they will, because they have to actively keep it there.
Well, I think they put a couple of solar observation satellites, not quite at that point, but on the other side of the sun relative to us, so that we can see the other side and get some advanced warning of large sunspots and things.
Oh, okay, good. But they have station keeping
Yeah.
facilities on them, do they
Yes.
not?
Yeah, they have to be active.
But it's at astronomical unit just on the other side, right? 93 million miles.
Yeah.
Same, like in our orbit. Wow. Stuff you learn these days. Amazing.
Yeah.
Okay.
Too
we got
far
a
away
month.
to repair.
Yeah. Better work.
Yeah. What a
There's
tragedy.
a lot of people biting their nails right now.
Yeah.
Right.
I was reading some articles about people who were expecting to work on it for, a year, 2 years, and they've been working on it for 16 years.
Right.
$10 billion. It weighs 7 tons. And I'll bet you if something went wrong, the man that made the cars that you guys bought would figure out a way to get on board a SpaceX.
Elon
and
Musk, yeah.
Send some guys out there to fix it like they did the Hubble.
Well, I learned that they have a shaker on board of it, thing to shake the whole satellite in case something needs to get a kick in the butt to get it
Say
going.
something neat in case something gets stuck.
Hey, what's going to happen? It looks like there's already a satellite out there. Planck satellite's already at the L2. They're going to run into each other.
Now,
There are several out there. There was a European Space Agency telescope, and it's a popular spot.
Tom, can you go to the little frame that's in the middle of the top of this picture? That one. This shows the gravitational fields as if they were hills. And you can see the L2, L1, and L3 are the crest of ridges of hills. And the L4 and L5 are too. Those are hilltops, gravitational hilltops.
Hilltops. Wow.
It's a
Yeah,
good
so if you put a
graphical
ball
record.
bearing there, it would not stay at the top. It would want to roll down no matter what way it goes.
Right.
Mhm.
Gee.
Okay.
All right. Sounds good. There's going to be, how do you hold your breath for 30 days? All those people in JPL.
Well, I think they probably held their breath the most when it was getting launched.
Yeah. Yeah.
That there would have been a rocket anomaly and it'd blow up.
So the toughest thing about making a satellite or an instrument for a satellite when I was doing it was what they call the shaker test.
Mhm.
For the last test before you ship it, you make sure that it works, everything works. Then you put it on a shaker and you shake it for longer than the according to the shaking profile of the rocket, launching rocket. And you shake it at a higher frequency and a higher amplitude than the rocket will endure or will provide. And I find those real nail biter things. I couldn't sleep the entire weekend when they did the shaker test.
So Jerry, where did you guys do your shakes? Did you do it at NASA Ames?
No, we did it here in Goleta. We had
Oh,
a high clean room. And
So
did
we
it.
used to take our experiments to NASA Ames, which is nearby Mountain View when I worked at Lockheed Research Labs. And they would shake the daylights out of them to make sure that the instruments would survive the
Right.
rocket liftoff.
Yeah, with margin.
And James
General
Webb got a little
Motors-
extra shake there when they were unpacking it.
Well, hell, it was on
General
a truck.
Motors, of which I worked, had their own big shaker made by Ling, L-I-N-G.
Uh-huh.
The power amplifier that drove it was 240,000 watts. And the shaker is basically a big loudspeaker, or the coil of a big loudspeaker. And we would shake all of our military electronics to make sure that nothing would come apart.
Mhm.
Yeah.
That's a vertical shake, but you also have lateral shake. And there you throw
Oh,
a big
okay.
weight around off center underneath of it.
So out at those research and development places where you worked, Jerry, back in the 80s, they had not only a clean room, they had a vacuum room and
Yeah.
a shaking room.
And a test room, yeah.
Of course, everything was clean as all get out, but
This was Santa Barbara Research Center then.
Yeah.
everything.
Yeah,
And a
we did.
lunchroom.
We didn't have a shaking room at Lockheed Research. We always sent them out to NASA Ames to do that.
Well, heck, they get shaken by just being delivered on a truck, wouldn't you think?
Oh,
Yeah,
that's
but not
mild
like-
compared to the launch.
Not like a launch, Ron.
Yeah.
I don't know how they do it, but I have a feeling they're going to pull it off.
Yeah,
It'll be a year before we see anything, won't it?
Oh no, I think 5 or 6 months from now, I think we'll see something.
yeah, we'll know.
Gentlemen, would you like to cover real briefly, as long as we're in a transition here with program number 44? This is New Year's Eve week, as you know, 2022, right around the hill.
Yeah.
Moon and the planets are lining up for a big send-off show for 2021. Moon passing, let's see, just under about less than a degree south of Mars as of noon on the 31st.
Yeah.
And then 4 naked eye stars, planets, Venus, Mercury, Saturn, and Jupiter.
Actually, on the 30th, on Thursday night, right at sunset, there's a really, really thin crescent moon that's going to be right next to Venus.
Mhm.
And then also Mercury will be
Mhm.
about a binocular to the left of that. So
Okay.
if you find Venus, you'll probably need binoculars to see the moon and Mercury, but you find Venus and then kind of come down to the moon and then crank over to the left to find Mercury. That's part of that lineup.
Yeah.
Okay.
I can get a picture of the crescent moon. They're very rare when they're this thin.
Yeah.
And then you might be able to see Saturn's moon as well, Titan, I think you mentioned.
Not in binoculars. You need a scope for that.
Right. It's getting pretty low, Ron. It's
Yeah.
getting pretty low now.
But Uranus and Neptune, but those you'll need a scope, won't you?
Yeah.
Not even.
Well,
Yeah. Yes.
Well, Uranus, if you're in a dark place, you can see with your eye, but
Yeah.
you need at least binoculars for those.
Well, how close are the 4 planets we can see? Venus, Mercury, Saturn, Jupiter. Are they in the same part of the sky?
Yeah,
Oh yeah.
They are.
they're all lined up in the evening sky. That's
Yeah,
what the
everything's
show is.
clustered around the sun right now, on one side or the other, morning or evening.
Yeah. So
Oh.
southwestern sky, Ron.
So when the sun goes down, they go down with it afterwards.
Shortly
Yeah.
after,
You don't have much time. Okay.
and some of them rise shortly before.
How about this? How about the summer triangle? A couple of those stars.
They're right on the horizon
Right.
Same thing.
when it gets dark.
We're not in a favorable position for summer stars.
And if you're like me and you want to see Vega in the morning, it's 5 o'clock. Vega comes up around 5 in the morning now as I see it.
And you can see it in the evening too, so you can catch it
That's
at
right.
both sides.
You can say good night and good morning.
Yeah.
Well, the
you know,
weather
this-
report for Thursday night is quite favorable. Few clouds,
good.
41 degrees, light winds, variable, 18% chance of rain.
If you
18?
believe it.
Doesn't sound
Well,
like
I mean,
good.
that's quite a ways out,
That's an 82% chance of no rain.
right?
Well, we need the rain, but we don't need it for looking. Shall we talk more about Mercury? It's on the other side of the sun.
Actually, let's jump ahead to Peekaboo.
Peekaboo. What the heck is a peekaboo cluster? By golly, it is
This is
Collinder 89.
is taken from a astronomy magazine, Sky Week thing. And I like to show pictures of what they talk about, but this is going to be a challenge for Tom because he always finds pictures of things while I'm talking about them. And that is Collinder 89.
And I
have
tell
searched
you-
the internet and I cannot find pictures of it.
They're very unimpressive, I must admit. Yeah.
Yeah, but that's famous for Stephen O'Meara. He's a visual observer and he's always pointing out things that are extremely obscure. As you know, there's a faint galaxy behind M13. And so we were at a star party at the 9,000 foot level of Mauna Kea with Steve. And he said, "Oh, look for the galaxy." And everybody goes, "Yeah, we've seen it." He says, "No, I mean the galaxy that's behind the galaxy."
Right.
And so he's always doing things that are very, very hard to see. And his favorite phrase was, "If you hesitate before you say I didn't see it, then you saw it."
Yeah. Yeah.
right.
I actually pulled that one in, Jerry, at Westmont through the 8, on a good night,
Okay.
picking up that
Well,
galaxy.
I couldn't find pictures.
6207, right? 6207, I think is correct.
Sounds familiar. Yeah, NGC.
It has no NGC number.
Well, this
Oh,
Collinder item doesn't. Yes.
Yeah,
Oh,
the
no,
Collinder
no.
item, Collinder 89 has no entry in any other catalog. So if you have
Oh.
another number that you think is it, you're wrong.
Yeah.
So
You can call.
I could find nothing for Collinder 89.
Tom,
Okay.
you can call it up in Stellarium.
Yeah.
Or you
Yeah,
can
I
call
did
it
that
up.
before.
Yeah.
I'm doing that right now.
It's really sparse.
Is that
Yeah,
it?
most of the Collinders are, pretty sparse.
Yeah.
They're pretty. They're all open clusters.
This is not it.
No.
No.
This is another hard to see object, though.
Well, is that a
Oh,
cluster?
2158. Yeah. Yeah.
Huh.
Where-
Can you find,
there is
can you
Collinder
find
there.
Collinder 89 in Stellarium, Tom?
Yeah, I found it.
Show it. I'd like to
So
see it.
Here we go. So here we are in wide view, and we'll zoom in here. There's Gemini.
It's worth, yeah, it's right next to Gemini's left foot.
Yeah. Propus.
But
Yeah.
I don't think it's kind of just it's an open star cluster, right?
Yeah.
Yeah. I think all the Collinders are. He was a Swedish astronomer, Per Collinder.
I don't see any designation for it.
Yeah. Stellarium does not have a picture of it either.
No.
It's got
Jerry,
CR89
If
there.
you want an easy Collender, 69.
No, challenge here is tough.
Yeah. 69, you can get binoculars. It's at the head of Orion.
Well, yeah. I mean, but the idea here was to look at Collinder 89.
Yeah.
And that's called a peekaboo.
That's why I put so much background in on Steve O'Meara, because I knew some stuff about him.
Yeah.
And he writes a column. Is this what he talks
He
about?
used to write a column for Sky and Telescope, and then he switched over to astronomy.
Right.
Okay.
Okay, I've got an image of Collinder 89. If
Okay, let's see it.
Okay, I'll stop share here.
okay, and let's see here.
Why don't you just throw it behind your head?
It's definitely unimpressive.
I'll be impressed.
It's a handful of stars making it an open cluster, right?
Mhm.
And it's the peekaboo. Why is it called the peekaboo?
You can't see it.
Sometimes it's there, sometimes it's not.
You know, Okay, Tom,
only
since I
about 20.
last shared a screen on Zoom, I've upgraded my operating system, and its new security settings aren't letting me share the screen. So trust me, it's very unimpressive.
It's only 20 stars.
Well, okay, here it is. I mean, I've got it here.
Okay.
So it says in Wikipedia, NGC 6087, also known as Caldwell. Is this? No, this isn't right. That's Caldwell 89, isn't it?
Yeah.
Yeah.
That's not.
No,
That's
no,
not
yeah,
Collinder 89.
Right.
That's not it. There's a Collinder
Is that
catalog,
CR89
and then
the same as Collinder?
No.
No.
Oh,
and yeah. So Wikipedia does not have an image for 89. It's called. It's an open cluster.
And you see
Cloudy Nights has an image for it.
there's no NGC number for it, and there's no M number for it.
Yeah, that's weird.
Yeah.
They used to call that the out of luck cluster.
So if one of our listeners will send in a picture of theirs of Collinder 89, or is it 98?
89.
89.
89.
89, yeah.
We'll figure out some sort of congratulations or prize for you.
Well, now he sounds like a version of your Stephen O'Meara. If he could see something that
Well, he was using a telescope, Ron.
Yeah, he's doing it visual.
it's not a naked eye, you can't see it that,
No, he's using a scope.
but it's
Here's-
peekaboo because you'll miss it, I guess.
We have a picture of him also signing one of our members' telescopes, Gary Peterson's.
Yeah, I think we saw that.
101.
Yeah, that was a picture that came out earlier.
I give.
I just sent you a link to a picture of Collinder 89.
From Cloudy Nights, you found it?
Right.
Show the picture of Gary and his telescope.
Yeah, I remember seeing that when we
All right,
put
let's
this
find that.
started today.
It's in the middle of his talking points.
Mm-hmm.
Yeah,
And
I
you want
supply the pictures separately to Tom.
Yeah,
When
got
would-
it.
President Jerry, when was he your friend, the columnist, the docent for a VIP tour of Mauna Kea Observatory in Hawaii?
That was 2004, Sky and Telescope and a company, private company, sponsored the,
Harry's on the right.
and Steve O'Meara for a week was the docent, one of the two docents for that thing. They supplied about half a dozen 12-inch Meade Schmidt Cassegrains
Yeah.
for the star parties that we had. This one is a star party at the 9,000 foot level of Mauna Kea.
Yeah, that's where all those 12-inch scopes are.
Yeah,
Steve O'Meara was just phenomenal as a teenager. They at Harvard, at the observatory at Harvard, they actually gave him the keys to the observatory so he'd go and look at stuff.
yeah.
Amazing guy.
He was seeing the radial spokes in the
That's
rings
him.
of Saturn visually.
Yeah.
Nobody believed him until a bigger telescope picked him off.
Yeah.
I'd say probably Voyager, right?
Yeah. He's also into volcanoes, so that's why he
Yes.
moved to Hawaii.
Yeah.
He gave us a nice volcano tour also.
Okay.
So this picture we're looking at was taken on that tour? Is that what we're talking about? Or is
Yeah,
it
this
you
was
said-
taken on the tour.
But
I
neither
also have a picture of him standing amid about 6 Meade 12-inch scopes all folded up in the airport. Or I was in the hotel lobby as they were unpacking them.
but
It was
these
a great tour. Froze my whatever off up there. It really is cold.
those two gentlemen, Steve and Gary, are in our club.
No.
Steve's in
No.
our club.
Oh,
Gary
wow.
was the docent on the tour.
Oh,
Steve was the docent on the tour.
Steve
Yeah,
is.
he was. Yeah, sorry.
Yeah.
I see. Gotcha. Right. Okay.
And,
Fantastic.
I met Gary thanks to Jerry, because he used to come to the gun club to observe now and then.
Yeah.
Doesn't he live like a Napomo, Jerry?
Yeah, he lives in Napomo.
Okay.
Wow. And world-class astronomer Filipenko up at Berkeley was in our club, wasn't he?
Yes.
Mhm.
That's some good. What are we looking at here? Is that Mauna Kea? Mauna Kea.
Mauna Kea.
This is at the 14,000 foot level of Mauna Kea.
Do you happen to know that the goddess of volcanoes is the same name as that Brazilian soccer player?
Pele?
Pele, yeah.
Mhm.
What the hell did he, which came first? I guess
Yeah.
the goddess came first.
Yeah, and I just learned the other day, thanks to a crossword puzzle, that Mauna Loa means long mountain.
Ah,
And Moana is mountain.
Yeah, there you go.
I heard they're getting snow in Hawaii.
I believe it.
Well, they will at the 13,000 foot level, certainly.
Yeah.
we're getting snow at Big Bear right now.
Well, we may be.
We're going to be
losing
getting
some.
snow in our mountains, maybe.
Yeah.
Oh,
I
yeah.
think I saw some the other day, Chuck.
Yeah. Yeah, a couple of days ago we had it. If you go to the Los Padres Firewatch webcams,
Mhm.
you can often see ice and snow up there at the very crest.
Well, the Peekaboo open cluster. Once again, tell me the difference between an open cluster and the other kind of clusters. They're tighter, more stars, right? The big, thick.
The globular clusters have more stars than their older stars, tightly gravitationally bound. And the open clusters are young stars, and they're usually loosely gravitationally bound.
And they're all in the Milky Way, and they're all like beehives going around each other while they.
Well, that's the globular clusters, yes.
Yeah.
But
Okay.
but they can be outside of the band of the Milky Way that you see in the sky because they're more like halo objects. Whereas the open clusters were often called galactic clusters because you tend to see them along the band of the Milky Way.
Right, right.
But this guy Collinder was almost a century ago, 31. He
Yeah.
saw your Collinder 89. That's what he's got. How many? 400 something in that 471 open clusters.
Yeah.
These are all stuff that Messier missed.
Well, it's
Yeah.
stuff that Messier wasn't interested in. They're not
Right.
generally really bright things.
Right. And,
Well, Messier was interested in comets, and they didn't look like
Right.
comets.
right. And he only
They
had,
did- they
he only
did
had a
move.
small telescope. He didn't have the bigger scopes that people later on had.
Who did? Messier?
Hit
Yeah,
a
Messier only had a
giant
3-inch scope.
Okay.
So let's go back to, because you raised the question about globular clusters. Up under the two favorite star names, below the picture shows the constellation Lynx. It's
Oh,
climbing
yeah.
above the horizon at sun, or climbing above the horizon, eastern horizon at sunset. And it has in it the globular cluster NGC 2419,
Ooh.
which is referred to as the Intergalactic Wanderer,
Yeah.
because it is nearly twice as far away from our galaxy as the Large Magellanic Cloud is. So it's way outside of our galaxy. And all these globular clusters are located in like an Oort cloud. It's a spherical congregation around our galaxy, whereas the Oort cloud is around our sun. But there's a spherical group of globular clusters around, orbiting our galaxy, but outside our galaxy and not in the plane of the galaxy. And this one is so far away that it's referred to as the Intergalactic Wanderer.
Right. We saw that at Westmont at a start, one of our Friday night things a long, long time ago when, and Chuck knows this telescope really well, when they had that reflector in the old dome.
The
And
16-inch.
and it was Chad. Remember Chad, Chuck?
Yes, I remember him.
He put it in his scope. Yeah, I think he had an 8-inch SCT. And that's the only time I ever saw that darn thing. Because we used to sit up on the lawn there near the scope, near the old observatory.
Mhm.
And you could get southern things there a little bit better.
Well,
Go
apparently,
look at astronomy picture of the day for June 4th, 2015. You can see a very nice picture of
Yeah.
that cluster.
is
Got
this,
a lot of
There, you
nice
got it. Yeah,
supergiants.
you got it.
that's the Wanderer on the right,
Yes.
The
It's a
globe.
glob.
and it's twice as far away as the Large Magellanic Cloud, which is a mini galaxy, isn't it?
Yeah.
Yes.
But this isn't.
No.
This isn't.
Nope.
Well, there is speculation that it might be the remnant of a galaxy core that we've completely absorbed as in the galaxy at large, but I don't think anything is really settled on.
It's fuzzy. It's just like most things in science, there's fuzzy edges to it where they integrate, interblend with each other.
Yeah.
You just have to decide at some point, oh, well, we're going to call this a galaxy or we're going to call this a planet.
But this is an object in intergalactic space. It's
Yes.
not our galaxy, so to speak.
And believe me, the globular that we saw in Chad's telescope looked nothing like this.
Yeah.
You need at least a 4-inch telescope to even see this thing.
Yep. I think Chad had an 8-inch SCT.
Yeah.
Yeah.
Well, may I ask a question, gentlemen of the Brain Trust? Since
Of course.
Andromeda is coming this way and is going to meet us in several, billion years, are these rotating, revolving, orbiting, like the interstellar and the Magellanic Clouds? Are they all going to come in and join the
No,
Milky Way?
they're not heading toward us, they're orbiting us.
Oh,
So as Andromeda gets close to us, it will have a strong gravitational effect on the orbit around us. And eventually it could fling these things off into space. They could just orbit the resulting 2 galaxies. You'd have to do some kind of a gravitational or orbit plot like Bruce did for our planet.
Yeah.
so this is called the local group, is it not?
The local group is spread all around us. We're part of the local group, yeah.
Right.
So Andromeda and us is in the local group.
Okay. Would it be fair to say we're the second in command? We're about half the size, I guess, of Andromeda. All the rest of them are little orbiting wanderers.
Well,
I don't
we're
know the-
comparable to Andromeda.
Yeah.
Are we?
Yeah.
Okay.
We're about third the size, right? We're about 300,000 light years across, and it's a million.
Well,
million light years
you know,
across.
you keep seeing that those estimates fluctuate, but now I think we're considered roughly the same size as Andromeda.
Yeah.
Okay.
Maybe a little bit
Miles
smaller.
diameter.
And this defies the Hubble prediction of flying apart. Were they?
Well, that's not a prediction, Ron. That's just an observation that the farther away something is, the faster it's moving away from you. And that's just a characteristic of an expanding universe.
Right. But these are close enough that their gravitational traction overcomes that flying awayness.
So that's done on a universal scale, and it makes for the threads, doesn't it, or the filaments? Because all these galaxies are coming together, but in the distance they're going apart.
Well, that's sort of a separate thing. That's more the distribution of matter you got at the end of the Big Bang
Okay.
that gives you that soap bubble filament type structure. They think it might be, concentrations of dark matter that cause a lot of that.
Are all the names on the screen we're looking at individual galaxies?
Yes.
Yes.
Every one of those.
It's like 30 to 40 of them.
And
Something like
that's
30 or
local.
40.
Okay. You suppose there's a big gap at the edge of this whole thing between us and the next local group out there that's got to be in another filament?
Well, we're kind of on the edge of the Virgo cluster, Virgo supercluster.
Super.
Yeah. The Virgo cluster and our local group combined make the Virgo supercluster.
Yes. Yeah, that's right.
Now, is that tied in with the zodiac sign on the ecliptic? Has
Nothing to do with that. That's all.
Well, that's the direction. That's the direction in which most of them appear.
Yes.
Right. But technically, most of the things we're looking at there are going to collapse in on us, or is that just going to keep orbiting like they do in clusters, stars? In other words, the only two that are going to merge are us and Andromeda?
No, eventually all those that are gravitationally in that influence would probably, depending on their velocities, tend to combine.
Do you suppose those little orbiters like the Intergalactic Wanderer has a black hole in the middle of them?
Could be.
I think there's one globular cluster they believe has a black hole in its center,
Well,
Uh-huh.
yeah.
and possibly others, but
Yeah.
nothing definitive, I think.
M15 in Pegasus, there off the nose of Pegasus, is the one that seems to have the best data for having a potential black hole at the core.
Mm-hmm, mm-hmm.
Certainly,
I remember
Andromeda
reading
does.
someplace that there are more black holes in the universe than there are stars. A lot of them are small.
Yeah, and I heard the same thing about rogue planets wandering
Well, you
without.
can't see them. They're dark.
Yeah. Anything
Black
could be
holes
coming
are real dark.
up. Fascinating stuff. Intergalactic Wanderer.
Mhm.
And it's not a Messier. It also doesn't have any of those other names you mentioned in the blue snowball thing about what did you call that? Was that the one we were talking about? No, that was the other one. Peekaboo cluster. We didn't get to the blue snowball, and we probably won't. What are we looking at now, Tom Totten?
There's some comments been going on between Tim and Jim,
Yeah.
and I'm trying to think what it was.
Purple.
Jim says there's a shaker and vibration shaker in LA at Hughes Satellite Facility. And then Tim says O'Meara had a Genesis scope from Teleview that he had to get clean because the acids that ate up the scope were from the volcanoes that he was hanging around.
Wow.
Yeah. All right.
Sulfuric acid, sulfurous acid too.
Mhm.
I'll tell you who may be watching us right now. A certain senior reporter for Channel 3 didn't know we were doing this, and I told him how to find out. He's very
It says
passionate.
right now it says we have 5 people watching right now, which includes me, Tim, and Jim. So there's 2 others I don't know.
Can you go back to the comments? I saw something about me and didn't get to read it.
Oh, that was about the deceleration of the JWST.
Okay.
Yeah. Jerry's a good guy, it said. Yeah.
Oh, good.
Well, we might as well wrap up by talking about that. Who knows when, what date, how long, how many months is it going to be in place? Is it a year?
It's got I think it's got a 10-year estimated lifespan for JWST,
Yes.
if that's what you mean.
Yeah.
No,
That's
I
right.
mean, when is it going to get there?
In a month.
Oh, in a month. And then we'll
The
start.
the timeline Tom showed at the beginning of our talk, the beginning of our hour, that shows how long it's going to take. Yeah,
Okay.
yeah.
It's in all the network news, and about all they say is the distant far side of the universe, 13 billion years. That doesn't say anything about exoplanets, which it's going to be looking into, isn't it? That's pretty big stuff.
It's looking into anything that's faint and slightly warm, and includes both exoplanets and Oort cloud objects and very early galaxies and stars.
Right.
And potentially atmospheres around exoplanets.
Yes.
Right.
Every time that astronomy has opened up a new wavelength band, new discoveries are made that weren't thought of.
Yeah. And this thing technically should see back about 100 million years after the Big Bang. That's going to be phenomenal. That's going to be phenomenal.
It's just hard for me to grasp that, because back then, what was the stuff that made us?
We weren't there. We would have been made out of hydrogen.
Yeah.
Yeah.
I know the hydrogen got nuclear fused into, carbon and other stuff later.
Yeah.
But somehow that poor light waves has been stretched and gone red, and now we can't see red, right?
Yeah, we can see red. That's what James Webb is going to do. It's going to see the ultra red.
Oh, I know.
Right.
But I meant,
The redder red.
are there attachments for telescopes like yours that can see infrared?
There are, but you can't see through the atmosphere.
Right.
You also
Some
can't
of
see
these
through the
wavelengths.
lenses.
Yeah.
Wait a minute. You can see through gas clouds to the center of the galaxy, which you can't see by your eye, but you can't see through our cloud cover?
Different gas, Ron.
The red is blocked because of water.
There you go. Look at that.
Well, also the lenses in your scope won't pass the long wavelength infrared too.
Right.
If they
That's
do,
why
they're
they
going
have
to be way out of focus.
Yeah.
That's why they have a gold-plated mirror.
Right.
And it's because the universe is expanding, the light waves get stretched, they go toward red. If it keeps expanding and it's even further away, do they stretch into the radio wave spectrum? They
Yep.
become
That's the cosmic microwave background.
Yeah.
Oh, microwaves is up
That's
there.
light waves, yeah.
They've been stretched long enough that they're now microwaves. They're not even.
Yeah.
Microwave is a band on the spectrum, right? On
Yeah.
electromagnetic
Right.
spectrum. Is it the frequency used in our radar ranges, our microwave ovens?
Yes.
you
Yeah.
think?
Yes,
Yeah.
our microwave ovens are about 2,400 megahertz, 2.4 gigahertz.
Yeah.
I see. Is it just one frequency or a little band of?
Oh, they try and do just one frequency. Ultimately, it is a little band.
Yeah, they don't want to interfere with a lot of other stuff, so they're assigned a band that they have to
Yeah.
verify that they're.
And that's microwave ovens, but microwaves is a band.
Yeah, it's 300 megahertz to 3 gigahertz.
But any part of the spectrum.
Or that's
could be-
UHF, I guess. I'm not sure.
but it causes food to heat up, or water molecules, I
Right.
guess.
You know how that happens?
You're going to tell me, Mr. Science Instructor.
Yeah, so it turns out that the reason that hot dogs heat up in your microwave oven is that hot dogs have water. And what the microwave oven does is it excites a vibrational mode. Oh, no, I'm sorry, a rotational mode in the water molecule. Okay. And those things bang against the meat and stuff in your hot dog, and your hot dog warms up.
And that's why you can't see it through the atmosphere. It's because the water vapor there does the same thing and absorbs the microwaves.
One time I had my students figure out just loosely the speed of light by using the frequency of the microwave oven and putting a couple of tabs of butter in the microwave oven, and therefore getting the wavelength, okay, of the excitation that goes on. And if you map the wavelength against the frequency, you can get the speed of light to within about 10%. It's pretty cute. It's a pretty cute way to do it.
But it's
what Tom's got up there now. Excuse me, Tom, were you done talking?
Go ahead.
Okay. You can see that as he's pointing out with the magnifying glass cursor, that's the part of the spectrum that James Webb is going to be looking at. And you see it's completely blocked by our atmosphere.
Yeah.
So that's where we're looking. Unknown territory.
Mm-hmm.
If we had evolved to have eyes that could see radio, we'd be able to see a lot more, as you can see there.
Yeah.
Right.
Yeah, it's just on the left edge of that plateau that James Webb is going to look at.
Mm-hmm.
Yeah.
But the Hubble saw some of those early galaxies in its deep field, and they were pretty messy globs of nothing organized, weren't they?
Yeah, a lot of them.
Because back then they weren't spirals, they weren't coagulated or organized.
Apparently those organizations started pretty early.
Yeah.
From what they're what's being indicated now.
Wow. It's now raining at my house. It hit you guys earlier. God knows.
Yeah, we just got rain. It's passed through.
Did you?
It's been coming down up here for all the time we've been talking.
Okay.
We're just getting a little gap here now.
Okay.
Is it true that the U.S. Navy uses the very low end of the scale at like 3 RPM or whatever it's called?
Hertz.
Submarines?
Yeah,
So
because that
they
will pass through the
transmitted
Earth.
What?
at 15 kilohertz.
15?
They transmit in the audio band, but it's not audio, it's radio waves.
Wow.
And their antenna is called Big Jim. It's up in Washington, and it's a wire that stretches from one mountain peak to another.
Wow. Fascinating stuff. Amazing stuff we're learning, and we're going to get some stuff from the web that will just dazzle everybody, won't we? Wonder when we'll start.
If it works, this is going to be a brand new world. Yeah.
Yep. We are
that
done.
and gravitational waves.
Yeah.
Chuck, before we go, have you occulted anything lately? Or
No, the clouds have been doing all the occulting.
Yeah.
Okay. Just for the benefit
there's one I have a shot at coming up later this week. I think it's on the 30th. Like Bruce said, it might be good weather, and it's a 100%er. So I'm hoping.
Wow.
Do all 6 of us plan to go anywhere for New Year's Eve Friday, or are we going to stay home and hope for a clear sky?
Not with Omicron.
Yeah.
Charles Schuler and I may go up to the end of Farron Road.
Oh, Bruce, I'll have to send you. I think I found another good spot.
Ooh,
Good.
cold as hell, but what the hell? Nice and cool out there. Gentlemen, we've run out of time. Happy New Year 2022. Maybe we'll get back together to repeat what we learned last week. February 4th, the first Friday of February, the second month of the new year, we're going to have an online get together if we can.
Yep.
Yeah. An administrative meeting.
Yes. Oh, that'll be the administration meeting, like our board meeting we had a couple of weeks ago.
So second Friday. Oh no, second Saturday.
Saturday.
Oh,
First
well, how about
Friday
January?
of February. The first Friday of February, we're going to start one of our monthly meetings of the general club with speakers.
Okay.
And you're going to pick, make a lineup or an agenda of 4 volunteers.
Well, I got 2 of them, the 2 in the middle of my screen. The 2 gentlemen at the bottom, Tom and Bruce, I guess, are not committed yet, but we'll talk them into it. What the heck? Keep it totally in-house. Take care of your wives, your family. I hope you got what you wanted for Christmas. We need the rain, but only in the daytime, not at nighttime. All right. We'll see you in the new year on the 3rd or the 4th, I guess. It'll be the 3rd, won't it?
Yep. Happy New Year.
All right. Happy New
Happy New
Year,
Year.
everybody. Thank you for watching the SBAU.
Thank you.
See you later, everybody. Take care.